Hello my dear students. Last class we have seen series and parallel circuits individually. So next topic is according to the syllabus, it is series and parallel combination. So series and parallel circuits. So if series and parallel circuits, if we see, so series separately we have seen and parallelly we have separate seen. Now we have to combine this series and parallel circuits. So if you see the series and parallel circuits, popular examples for this is a star connection, that is which we are using in the three-phase circuits, and delta connection. These are all used for three-phase circuits. They are also comes under this series and parallel combination. And one of the popular examples which are asked in the previous exams is like this. So you are having a resistor and the two resistors are connected in parallel like this. So this is one of the example just I have taken from the previous paper. So this is the resistor R1, this is the resistor R2, and this is the resistor R3. So if you see this resistor R2 and R3, after coming to this point, the current is divided like this. Current is divided. So that is some current, just I am assuming here, that is I1 is flowing and I2 is flowing. So that means current is division is possible. That means here R2 and R3, they both are connected in parallel, we can say. So they are getting some equivalent resistor after getting some. So just I am writing it as RP. So what is the RP we can write? That is R2 in parallel with R3. That means I can write it as R2 R3 divided by R2 plus R3. So this is the RP. So you are getting now what is the equivalent of this RP. Next, what is the total equivalent of this entire circuit? You can take it as R equivalent, we can write it as, that is R1 in series with that is RP. Is it right or not? So right. So R1 plus what is the RP value we have written? That is R2 R3 divided by R2 plus R3. So just as I am going according to the syllabus, so this is the one of the example. So let us, I will draw the what is a star connection and what is a delta connection. Here no need for you, but just you see what is the star and delta in detail we will see in three-phase circuits. So here, so this is the one of the, this is the example of the star connection, and this is the delta connection. This is the delta connection. Like this, you may have in the place of the resistor, you may have the inductors, you may have the capacitors also. How they are saying it as, they are also examples of series and parallel circuits is, if you see this circuit from this side view, if you keep your eye on this side, so it is looking like some series and parallel circuit. Like this, same delta also, if you see from this side or this side, if you see, or this side, if you see, this side, all this side, from any side you see, you can see some series and parallel combination you can observe. So in-depth observation required for this series and parallel connection of the star and delta connection. So let us move on. So as per the syllabus, next topic it is given it as the what is the power, what is the power, what is the electric power. So for defining the electric power, just I am taking a simple circuit here, which is consisting of a simple resistor. So resistor here, and it is connected with one voltage source, right. So like this, so voltage source, some current starts flowing like this, resistor is there. So as you know, the property of resistor, it is just opposing. So whenever you are applied some voltage, charge starts flowing, that is a charge is starts flowing here, charge is flowing. So whenever you apply some voltage, the charge will starts flow here. So depending upon that, we can take what is the, so based on that I will take one derivation for the power. So there is some opposition is there from this resistor. To overcome this opposition, this voltage source has to do some work. The work done by the voltage source within a unit time, we can call it as the electric power. So the work done by the source within a unit time, we can call it as the electric power. So we can take the definition. Power is the measure we can take that definition. Power is the measure of, so just I am writing the definition here. Power is the measure of how much work done, how much work done, work can be done or performed in a given amount of time, in a given amount of time, in a given amount of time. That is known as the power definition. So whenever you see the power definition, so you can get the, so different concepts we have to apply here. So you have to see the current, you know the current formula, current is, that is I, we can write it as Q by T, Q by T. Next Q you can write it as from this I into T, is it right? So next we know the voltage. So what is the voltage? Voltage is equals to work done on the charge, is it right or not? So voltage is, the voltage we can define it as work done on the charge. Here you can write it as work done can be written as V into Q. So if you substitute here, so Q here in the below equation, Q you can write as I into T. So what is the power it is defined? Power is defined it as, so the amount of work done per amount of, that is the amount of work done in a given amount of time. So work done in a given amount of time, that is known as the power. Work done divided by time, you will get the power. So if you see the work done here, how much you got? That is V into I into T. The time also we are taking it as T. T will get cancelled. So what is electric power defined? Electric power defined as V into I. So V into I you can write as another formula from the Ohm's law for I, that is V by R, that is V square by R, and another formula for V from the Ohm's law, that is I into R, that is I. So what we can write? I square into R, that is known as the power. So what is the units? When you come for the units, so work done can be taken it as in the joules and time can be taken it as seconds. So joules per second is the units for power, or you can take the units are also watts. So watts was very popular we are using. So watt means, so if you take so for example kilowatts, what is the kilowatts means? That is 10 power cube watts, 10 power cube watts. Megawatts means 10 power 6 watts, 10 power 6 watts. So 1 HP, 1 horsepower is 745.6 watts. So HP conversion, so that is horsepower can be converted into 745.6 watts is the units. So this is about the what is the electric power. Now we will see what is the energy, what is the electrical energy. We will see what is the electrical energy. So now we will see what is the electrical energy. So if we see the what is the electrical energy, the amount of work done in an electrical circuit, the amount of work done in electric circuit, in electric circuit is known as electrical energy. So if you see the electrical energy, so we can write it as electric power into time, electric power into time. What is electric power you got? That is V into I into T, or I square R into T, or V square by R into T. Like this, different forms of electrical energy you can see. This is the different formulas for electrical energy. when you see the electrical energy units, so what is the units for power? Power units are, we are taken it as watts. So different depending upon the time. If time is measured in hours, that is watt hours. If power is measured in kilowatts, that is in kilowatts. If the time is measured in hours, that is watt hours. If the time is measured in seconds, watt per second. So if the time is measured in seconds, here kilowatt per second. Like this, depending upon the time, we will have different formulas, and depending upon the watts also, we have the different formulas for the electrical energy. So this is the definition of the electrical energy, and the units are this is of units for the electrical energy. That's all for today's class. We will stop for today. Thank you attending this class. Thank you very much.